All right, Algebra 2 students, this is your warm-up for March 19th, aka Thursday, and I'm going to try to do less me, more you on the simplification, but I am going to give you two problems that do tend to mess people up. So, on the first one, in the numerator, we have x squared minus x, and the denominator is 5x minus 5. It's a little tricky, but they're both GCFs, greatest common factors. So this one is going to become x times x minus 1. Okay, and both of these have a 5. Watch your signs very carefully, and so you'll have 5 over x minus 1, and I'll leave the rest to you on that one. So again, not done, but you can do that part on your own. I believe in you. All right. Two interesting problems to factor before doing our GCF. Remember, we're always going to factor first. That's always going to apply. So when we come to 2, can't scooch as far as I thought. All right, let's look at something that multiplies to the end and adds up to the middle for our trinomial x squared plus 8x plus 16 in the numerator. So what multiplies to 16 and adds up to 8? You got it. X plus 4, x plus 4. Okay, it's been a minute since we've seen one of those. Now, the denominator is x squared minus 16. Now, this is a special kind of factoring. It is technically quadratic factoring, not GCF. Take a minute if you can remember what it is. All right, it's going to be a difference of perfect squares, which means it's going to be the same number twice. That multiplies to 16, but one's going to be positive, one is negative, so they add up to 0, and that is 4 and 4. So when you're working through this one, look what actually cancels. Again, not finished, but you can finish it and turn that in on your warm-up, okay, guys? So think about what cancels. Does it all cancel? Are you sure? Has to match exactly. All right. And then today's lesson is going to be about adding and subtracting. So we're going to look at old school adding and subtracting fractions, which I know has been a bit of a minute. Rearrange my limbs. Okay. So number 3 here, what we're looking at is 5/4 plus 2/3. Now it's really tempting to add everything together, but adding doesn't work that way. When you add things, they have to be like terms, right? Well, fourths and thirds aren't alike. Is there anything we can do to make them alike? Well, what if I multiplied this by this one's denominator, 3/3, okay, and this by this one's denominator, 4/4, okay? So what that's going to do is say 3 times 5 is 15, and 3 times 4 is 12, right? 2 times 4 is 8, and 3 times 4 is 12. Now, if they're both over the denominator 12, they actually can be added because now they're alike. Very important when adding fractions. Add the numerator. So 15 plus 8 should be 23. Yes, not losing my mind. 23. Leave the denominator alone. Well, it's easier if you think of it, it's in parts. I've got 15 out of 12 parts plus 8 out of 12 parts. So now I have 23 out of 12 parts, okay? You don't add those bottoms. Subtraction is actually pretty much the same thing, except you subtract. Now this one I can do a shortcut. Could I multiply this one by 8/8 and this one by 4/4? Sure, but I could also say, hey, I know how to get from 4 to 8. Multiply by 2. So this becomes 6/8 minus 9/8. So they are like terms. 6 minus 9 is -3/8. And that's subtraction. So adding, subtracting, you have to have the same denominator. How do you think that's going to affect our rational functions? It'll be a little tricky, but we'll handle it. Good work.